For section 9.2 and 9.3, they're going to narrow it down to a more specific type of sequence. So for 9.2, we're doing arithmetic sequences and partial sums. For 9.3, we'll do geometric sequences, and I think that you have seen these in Algebra 2. Okay, first off, arithmetic. When used as an adjective, you say arithmetic. When it's a noun, like go do your arithmetic, you would say arithmetic. Okay, anyways. Okay, a definition of an arithmetic sequence. A sequence is arithmetic when the differences between consecutive terms are the same. So if this was my sequence A1, A2, A3, A4, etc., if I went from A1 to A2, I add some value D, and then I add D the next time, and I add D the next time. And D could be negative, but D would represent the difference. If you need to find the difference, you could also do something like, okay, A2 minus A1, subtract any two consecutive terms. Okay, and you should figure out what the difference is in that sequence. Okay, so for example, one, you just have to look at it and see if it's arithmetic. If it is arithmetic, indicate what the value of D is. Okay, so you don't have to do subtraction, you don't have to use a formula, you just have to look at it. So if I check A, it goes from 2 to 5, so it's increasing by a difference of 3, increases by 3, increases by 3. So from what I can tell, this is arithmetic, and the difference is positive 3. And we will assume that that pattern is going to continue. For the next one, same, I'm just going to check and see it. See, the difference here is going up by 2. Now it's going up by 4. So this is not arithmetic because it doesn't increase or decrease by a constant value, or D. Okay, for C, same idea, but it is fractions. So in order to tell what the difference is going to be, I'm actually going to do a common denominator first. So let me rewrite this as a common denominator of 6. So this would make this 3/6, 2/6, 1/6, and it's going to keep going from there. Okay, based on, now that I've rewritten it, it's a little bit easier for me to tell that it looks like the numerator is going down by 1. So the difference is negative 1/6, and yes, this is arithmetic. Okay, so if it's fractions, sometimes you have to adjust it a little to easily see the difference. Okay, now for example 2, it says find the next 3 terms of the arithmetic sequence. Because they're telling you it is arithmetic, you can assume that the difference is constant. And then they want you to find AN. AN would be to find a formula representing each term based on its term number. Okay, so if I just glance at A, what does it look like it's going up? It looks like it's going up by 4. Okay, if it is in fact arithmetic like it says, it should continue to go up by 4. So 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 4 is 21, 25. Okay, now I'm going to find a formula representing this sequence. I think you can do it in your head, and I'm okay with you doing it in your head. I can also show you a second method to find it, and then there's also the book method, and I'm going to be fine with any of those 3 for arithmetic sequences whenever you can tell. Okay, I'm trying to find the formula for the nth term of the sequence. Okay, because the difference is 4, I'm going to start out with 4n, because with each term it goes up 4 more. Okay, now I need to figure out if there's a constant that I need to add or subtract in order to make this work, because 4 times n is actually not correct at all. Okay, how do I know it's not correct at all? Is because the first term is 5. So I need to adjust this formula to make sure that when I plug in 1, I get 5. Okay, so if I plug in 1, I get 4 times 1 is 4. In order to get 5, I need to do plus 1. Okay, so this is my formula. I did do it in my head. I'm going to double check to make sure it works for the next term. So 9 is the second term. If I plug in 2, 4 times 2 is 8. 8 plus 1 is 9. For the third term, 4 times 3 is 12. 12 plus 1 is 13. So it works for all the terms. And I'm okay with you doing it like that in your head. However, I know some of you like a formula. So I will show you one formula, and then you will look in your book for another formula. And I'm okay with you doing it any of these formulas. Okay, if I want to use a formula, I'm going to start off with the fact that a to the n equals, because the difference is 4, I'm still going to start with 4n because it goes up by 4 with each term. And then I'm going to try to figure out what the constant is at the end of this term. Okay, now if I use it, this method, I could use any of the terms. I could plug in the first term, the second term, or the third term. Okay, so if I start with the first term is 5. So I'm going to put a 5 here. 4 times, since it was the first term, n is 1. Okay, and if I solve this, I get k is 1. And that would still give me the same formula that an equals 4n plus 1. You don't have to do all that work, but you are welcome to if that helps you figure out the answer. And sometimes you might switch back and forth depending on the scenario. Okay, for B, I'm going to do the same thing. It's arithmetic, so I'm going to find the difference first, and then I'm going to go with the difference. So it looks like it is, what is this, minus 3? 4 minus 1 is 3. Okay, I'm going to keep going down 3 each time. So minus 2, minus 5, and minus 8. And then because it wants me to find an expression for a sub n, I'm going to find an expression for a sub n. Okay, so a sub n, because it's arithmetic and the difference is negative 3, it will be negative 3n. Now I'm going to adjust it because the odds that that is correct is very low, just the way it is. Okay, so the very first term is this one. So when n equals 1, I should get 7. Okay, so if I plug in n equals 1 here, negative 3 times 1 is negative 3. In order to get 7, I would have to add 10. And yes, I'm okay with you doing this in your head, but I'll show you how to do it without. Okay, that means for the second term, if I plug in 2, negative 3 times 2 is negative 6, plus 10 is 4. This is the third term, negative 3 times 3 is negative 9, plus 10 is 1. So it does work, and I would double check to make sure it works before you move on. Okay, but let me show it with the where you solve for the constant as well. Okay, so if I wanted to do it more like a formula, I could say a sub n equals, the difference is negative 3, so it's still negative 3n, but I want to figure out what I add or subtract to the end to make this work. Okay, I'm going to use the first term, n equals 1, but you could use the second or third or any of the terms. Okay, so if I use the first term is 7. 3 times, since it was the first term, n equals 1. Okay, I still get k equals 10. And so now when I write my formula, it's negative 3n plus 10. And I still might check it on a couple terms just to make sure it's correct. Okay, I'm going to keep going. Okay, I'm going to go ahead and look at example 3. Example 3 says find the missing term of the arithmetic sequence. And again, if it says arithmetic, I can normally find a shorter way to do it. If it doesn't say arithmetic, then I have no idea. Okay, so it tells me the first term is 3, the second term is 8, and the 10th term is, I don't know. That's what I'm going to try to find. Okay, there is more than one way to do this. Okay, I'm going to show you 2 ways to do it, but that doesn't mean there's not more ways to do it, as long as you're justifying it using what we learned. Okay, because they gave me the first term and the second term, I do actually know what the difference is. So the first term was 3, the second term was 8, so the difference must be 5. Because I know the difference, that gives me some options in terms of how I could find it. Okay, so let me see. One way I could find this is I could say, okay, I want to find the 10th term. What do I know? I know the first term and the second term. Okay, now say I start with the second term. There's no particular reason I started with the second term. Okay, to go from the second term to the 10th term, I would add 5 8 times because it's 8-term difference. Okay, so I'm going to say I'm going to add 5 8 times because that's the definition of arithmetic sequence. Okay, I could use this setup to solve for the 10th term. What is A2? A2 is 8, so 8 plus 40. I get that the 10th term is 48. Okay, so this is one way to solve it. Okay, I'm going to show you a second way to solve it, and again, I'm fine with either way, depending on what you prefer. Okay, the second way I might solve this is because I already know what D is, I could come up with the formula fairly easily. Okay, so let me see. If I wanted the formula for n, I would say an equals, because the difference is 5, it would be 5n. Okay, and then I just need to figure out what I add or subtract to make this work. When n is 1, I get 3. So 5 times 1 is 5. In order to get 3, I would need to subtract 2. Okay, this is my formula for a sub n. Because I have the formula for a sub n, to find a sub 10, I could then plug it into the formula because now I've established that there is a formula. Okay, I still get a sub 10 equals 48, and I still showed my work. So whichever way you would prefer to do it in this case would work. Okay, there are times though when you don't have as many options, but you can still kind of be creative about this. Okay, so I'm gonna look at example 4. For example 4, it's very similar, kind of. Okay, they tell me that the 4th term is 7, and the 10th term is 25. I wanna find the nth term, so I wanna find the formula. Okay, now let me see. If they gave me consecutive terms, it would be very easy to find the formula because I would have D already. So again, I'm going to show you more than one way to do it, and you're going to decide which way makes more sense to you, and you're going to do it that way. Okay, one way to do it would be to kind of see what I have and see what I need to add to get there. Okay, so I have the 10th term. I know the 4th term. Okay, in order to go from the 4th term to the 10th term, I would have to add the difference 6 times. If I knew what the difference was. I don't know what the difference is, but I know what the 10th term and the 4th term is. So because the 10th term is 25 and the 4th term is 7, I can plug that in, and now I can solve for D using that information. So 18 equals 60. Okay, I get D equals 3. Okay, am I going to show you another method? Yes, I am. And I'm going to be okay with you doing it either way still. Okay, the second method uses the fact that if you think about if it's going up at a constant rate, that's the same as the slope of a line. Okay, so the second way to find the difference could be, I'm going to use essentially the slope formula, where this is the y minus the y. And then the x's are going to be this and this. 10 minus 4. I get 18 over 6, which is still 3. And it's just stating the rate of change, which is the slope, which is also the difference. Okay, you only need the d in one way, so whichever way works for you is fine. Okay, I still need the formula for a sub n. And again, I've showed you a couple ways to do that. Okay, but now I know the difference is 3. So I know it's going to be 3n plus something. Okay, I'm going to put it in a k here. Sometimes when it's higher, I don't want to do it in my head. Okay, I can use the 4th term or the 10th term to figure this out. I'm going to use the 4th term. Okay, so the 4th term is 7. And because it's the 4th term, n is 4. Okay, so my formula for an is 3n minus 5. Okay, and again, once you're done, I would just double check in your head real quick. If I plug in 4, 3 times 4 is 12, 12 minus 5 is 7. If I plug in 10, 3 times 10 is 30, 30 minus 5 is 25. Okay, I am about to give you, show you some formulas for the sum of finite arithmetic sequences. These are finite sequences because if it was an infinite sequence, it would add up to positive or negative infinity. So there's no point in adding it. Okay, so I'm going to show you where they derived the formula from because it's actually a very common problem. And, you know, it's fun. You don't have to copy this now. I'm not going to ask you to do this again. Okay, so if I want to add the first 9 terms of this sequence, 5, 7, 9, 11, and it's arithmetic, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's what I want to add up. But this could be the first like 100 terms of the sequence. It could be something that's really big, or I might not have a calculator, or I just don't want to add it, or I want to do it a cooler way because I'm cooler than that. Okay, so the way they come up with this formula is I'm going to rewrite the exact same sequence below it in the opposite order. So instead of 5 plus 7 so plus blah, 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 I'm going to do 21 plus 19 plus 17 plus da 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 da. Keep adding forever. Plus something something down to the 5. Okay, now why did I do that? Okay, now I'm going to add these together. It's going to give me the answer times 2 because I am adding it twice. Okay, but it's going to turn out nicer. So if I do 5 plus 21, I get 26. 7 plus 19 is 26. 26. And if I keep going, this would just end up being a bunch of 26 added together. So the formula is basically, how I could figure this out easier, is I would do 26 times how many terms are there? There's 9 terms, so I have 26 times 9. But because I added the sequence twice, I am going to divide by 2. And this would give me the sum of the first 9 terms of the sequence. Okay, now I'm going to switch to the formula for the sum of a finite arithmetic sequence, and you're going to kind of keep in mind this process because this is going to match the formula. Okay, so the sum of a finite arithmetic sequence, depending on the number of terms, is n over 2 times a1 plus an. This matches the previous formula because if you remember, we put it in order and then we put it backwards. So this ends up being the first term plus the last term. I multiplied it by the number of terms I was adding, and then I divided it by 2 because I had written out the sequence twice. So that is why this formula works. That is where the formula comes from. Okay, now let's try the formula. And yes, I think we are going to give you the formulas on the test. Okay, so what does this say? It says find the sum of 56 plus 50 plus 44 plus 38 plus da 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 down to 20. And yes, I know you could put all of those terms in the calculator, which is why I will make sure on the test it's something you can't evaluate on your calculator. Okay, now what's the first issue? Okay, the first issue is that this formula asks me for Sn, and I don't know what n is. So I'm going to have to figure out what n is. Okay, to do that, I think I'm going to actually figure out the formula for an real quick. Okay, what is the difference? The difference is going down by 6, which means that an equals negative 6n. And then what am I going to multiply to make this work? The first term is 56. So negative 6 times 1 is negative 6. In order to get 56, I would have to add 62. Or you could put plus k and solve it out. I'm fine with either way. Okay, now I'm trying to figure out how many terms there are. So I'm going to look at the last term. And I want to figure out what n equals at that point. So to do that, I'm going to plug in 20. And then I'm going to solve for n to see which term that is. Okay, so 20 is actually the 7th term. So now I can use that formula. Okay, so I want the sum of the first 7 terms. Okay, and the formula tells me do n divided by 2, the first term plus the 7th term. And then honestly, I'm okay with you putting that entire thing in your calculator. I get 266. And no, I don't know what we're going to do on the test, but we'll figure it out by then. Okay, so the sum of the first 7 terms would be 266. If you wanted to confirm, you could add up 56 plus 50 plus 44 plus 38 plus blah, 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 and keep going like that. Okay, let's play with this formula a little more. Okay, for example 6, it says find the partial sum from n equals 1 to 22. And I can use the formula for this problem as well. The way I know it is arithmetic, because if I look at the formula, it's 1 times n plus 5, so it's going up at a constant rate because it has that 1n there. And actually the difference would be 1. Not that I need it right now, but it would be 1. Okay, I'm going to try to do the formula again. Okay, so according to the formula, it's n over 2. Okay, and then I want to add the first term plus the 22nd term. Okay, they didn't give me the first and 22nd term, but they gave me the formula, so I can use the formula to find the first term. Okay, so 11 times, okay, what formula? They gave me this formula right here, because that's in the thing. that's in the parentheses. Okay, so if I plug 1 in here, 1 plus 5 is 6. If I plug in 22, 22 plus 5 is 27. Okay, and again, just put it in your calculator. But make sure you're getting the same answer because sometimes calculators are harder than the actual math. Okay, one more. And we're still using the same formula. It's just what you do when different terms are missing. Okay, the last one says find the nth partial sum where n is 50. In this case, I do not want to have to put 50 numbers in my calculator at all. Okay, so in order to do this formula, what do I need? I want to find the sum of the first 50 terms. So I'm going to do n divided by 2. Okay, I'm going to do the first term plus the 50th term, and I don't actually know what the 50th term is. Okay, so there's a couple ways I could figure out the 50th term. I could figure out the formula, which wouldn't be that hard to do. It looks like it might be 3n minus 14, but I'm going to show you a second way so that you could also do it a different way. Okay, another way would be to think about, I want the 50th term. I know the first term, and I know the difference is 3. Okay, so if I went from the first term to the 50th term, I would add 3 49 times. Since A1 is negative 11, 3 times 40, what is 3 times 49? 147. So the 50th term would be 136, and that was what I would input in here. Okay, and again, you could have figured out AN and then plugged in the 50. That way is also completely fine with me. Okay, from here, put it in your calculator. And I get 3125. And again, if you really wanted to check it, you could add the sequence all 50 terms in your calculator to double check your work.